Hi there, and welcome to lesson 4 of our topic of nutrition and digestion. Lesson 4, we're going to be looking at energy requirements, and I've already opened up a calculator here as this lesson will require it. There's a little bit of maths, but the equation is given and it is pretty straightforward. So, without further ado, let's take a look at our key words. The first keyword is joule, of course, which is referring to energy. Because we'll be doing energy requirements for a typical person, we're also going to have to do some basic energy calculations, and we have to know our unit. So, secondly, we have calorie, which is the most common term we hear when we think about food and energy. We have carbohydrate, glucose, and lastly, respiration, how we make energy. So I'm going to make a quick note here. Joules, reference to the unit of energy, as well as respiration, how the human body makes energy. So, take a moment here to pause the video and complete the knowledge check for lesson 4. Carbohydrates are used for quick energy release in the body. Typically, we find them in sugars and starches, and they're broken down relatively quickly so that your body can get energy it needs. And you find these in things like starchy foods, breads, pastas, or you would find them in things like fruits. Question 2, state the function of lipids, slow energy release, as well as insulation. Lipids are very important as they allow your body to have some form of insulation and manages the body's internal temperature. Question 3, state the function of proteins. Proteins are used for the growth and repair of cells. We get these proteins from things like meat, fish, nuts, as well as other alternatives. 4, state the function of fiber. Fiber aids in the movement of digestion, so it helps you digest your food by moving it through your intestinal tract. 5, suggest 2 foods which contain fiber. Fruits and vegetables are the primary way that most people get their fiber. However, you can also get them from things like oats or wholemeal. 6, state the symptoms of lack of water. Lack of water is basically dehydration, and when someone is dehydrated, they typically get headaches. The more dehydrated they are, they'll start become dizzy and nauseated. 7, suggest 2 parts of the body that need minerals. Your bones and your teeth are the first 2 things that we should think about, as calcium and magnesium are extremely important in maintaining healthy bones and teeth. Lastly, 8, state which type of fats are better for you. When it comes to fats, there are good types of fats, and of course everything in moderation. Unsaturated fats are the most healthy type of fats for you. So moving forward, we're going to take a quick look at our lesson overview for today. We're going to state the main fuel of the body. And if you hadn't guessed from our key terms, it's going to be carbohydrates. Secondly, we're going to calculate basic energy requirements, or the BER, of a typical individual given their mass. So, in order for the human body to function, it needs energy. And energy isn't something that necessarily just comes about. We have to consume it and we have to intake it to acquire this energy. Chemical reactions in your cells help build molecules, as well as your muscles need energy to contract so you can move. But more than that, you need energy to keep your body temperature at a constant rate, as well as for your brain to function. It's really important that we have enough energy to be able to efficiently complete tasks, as well as be able to think, act, move, breathe, and maintain our body temperature. Mitochondria in your cells release energy from your food. And they do this by breaking down a molecule called glucose. The process in which it does this is called respiration. Respiration is the production of energy using mitochondria, and it requires oxygen in order to happen. So most of the time, people confuse respiration with breathing. But respiration is not breathing. It's the usage of the oxygen that we breathe in order to break down glucose to acquire energy. So I'm going to make a quick note here about respiration. Respiration is the usage of oxygen gas to break down molecules such as glucose to convert it into energy. In order for respiration to happen, you need fuel. And of course, this fuel is carbohydrates or sugars. Everyday activities require energy, so it's important that you actually eat the right amount of food so that you can have enough energy for the day. And if you're someone who carries out a fairly active lifestyle, you know that it's important that you have things like snacks so that when you go into whatever activity you're doing, you have enough energy to complete it. So please take a look at this clip below and write down some key points in the video. It'll be linked in the description section of this video. So something to keep in mind is different people have different energy needs. Just like the appliances in your home, different electronics will need different amounts of energy depending on their job. The amount of energy we need depends on many factors, but the main two we want to look at is your mass and how active you are. The more cells you have, or the greater the mass you have, of course you'll need more energy. There's more cells that require that energy in your body in order to help keep you alive. Additionally, the more active you are, the more energy your body will need in order for it to complete its tasks. You get the energy your body needs from things like fats as well as carbohydrates. So it's important that we take in enough of these, but of course, everything in moderation and not too many at one time. There is a balance in which we have to intake our energy. An imbalance could lead to possible health problems down the line. Take a look at this clip below and write the conditions that can result from an imbalance of energy intake. In a previous lesson, we have already discussed what the problems might be if someone has a high intake of something like fats. With that in mind, we need to calculate how much each person needs when it comes to energy. So we call this our basic energy requirement. To calculate basic energy requirement, we have to multiply 5.4 kilojoules by 24 hours multiplied by the body mass of an individual. Of course, kilojoules is referring to our unit of energy again. 24 hours for the time in the day, and body mass is in kilograms. So I'm going to make another quick note that you should be taking in too. Kilojoules refers to the unit of energy, 24 hours for the time in a day, and lastly, body mass is in kilograms. So for us to calculate basic energy requirement, all we need to do is plug in the body mass of an individual. So let's give it a go in this learning activity here. We're going to complete the table, and like I said before, we're going to need our calculator. So I'm going to pull up my calculator, and following the equation above, we're going to multiply 5.4 by 24 hours in a day, and lastly, we just need to multiply by the body mass of the individual, which is 60. And we get 7,776. Their basic energy requirement for an individual with a body mass of 60 kilograms is 7,776 kilojoules per day. every day, they're going to need roughly that amount of energy in order for them to just be able to complete their daily activities. So we're going to put this in here, 7,776 kJ per day. Next, we do the same thing, 5.4 multiplied by 24 multiplied by 88. So 5.4 times 24 times 88, and we get 11,404.8. Let me just do that again. Lastly, kilojoules per day. And that's all there is to it. This isn't a very complicated equation. It's just multiplication, and you will be able to use a calculator if this shows up on a test or a quiz. So take a moment here to complete the remainder of this table, and we'll take it up in just one moment. So now that you're done, please take it up and check your answers with mine on the side here. Give yourself a green tick if you complete it correctly. If not, please green pen in the correct answers. Again, straightforward, just follow the equation which I'm going to copy down again on the right hand side. 5.4 kilojoules multiplied by 24 hours multiplied by body mass in kg. All right, so let's move on. Let's describe the trend in this table. What do you notice about the numbers? Are there any two that look very similar, or if there's a pattern that you see? Take a moment to just think about this before listening to the answer. If we look at this table again, of course, we notice that the energy required per hour per kilogram is always the same, as well as, of course, the hours on Earth in a day are always going to be 24. What basic energy requirement actually cares about is the body mass. The larger the body mass, the higher the basic energy requirement, and that's our main trend. The greater the body mass, the greater the basic energy requirement, or BER. And we've talked about this already. Someone with a larger body mass simply has more cells in which will require energy to survive, and therefore they're going to need more energy over the course of a day than someone with a smaller body mass than them. Question 3. Walking uses an additional 400 kilograms, or let's look at question 3. Walking uses an additional 400 kilojoules per half an hour. A person whose mass is 55 kilograms also walks for an hour. Work out their total energy requirement for the day. So this question may seem confusing, but there's only two parts to it. Of course, first we just need to figure out their daily basic energy requirement. Just like before, we have our equation, which is 5.4 kilojoules multiplied by 24 hours multiplied by their body mass, which here we find is 55 kg. And by multiplying those three numbers, we'll be able to figure out what their daily basic energy requirement is. So 5.4 times 24 times 55. And we find that their daily basic energy requirement is 7,128 kilojoules per day. Lastly, we find out that this person has been walking for 1 hour. And given the question, we know that when someone is walking, they burn an additional 400 kilojoules per half an hour. So if they've been walking for 1 hour, we just need to multiply our value by 2. So 400 kilojoules per half hour times 2 will give us a total of 1 hour. 400 times 2 is 800 kilojoules, and we just add it to our other value, the basic energy requirement that we know this individual will be using in that day. So we get a total of 7,928 kilojoules for the day. Is this individual's BER. And that's it. Again, this equation itself, quite straightforward. It's just multiplication, and all you need to do is find out the body mass of the individual. The second step is just adding in how much energy they're using for walking. So take a moment now to complete the final knowledge. check of lesson 4. All right, all finished? Let's take it up together then. Question 1, name the 7 nutritional groups. We learned this 2 lessons ago. We have proteins, carbohydrates, lipids, minerals, vitamins, fiber, and water. Out of these 7 groups, which group provides energy? The main group for energy is carbohydrates, as well as lipids. 3, state which group is needed for healthy blood, bones, and nerves. Well, even if you're not sure about blood and nerves, we know what we require for bones, and that, of course, are minerals. 4, state which group prevents constipation. Fiber is that group which helps aid in our digestion and the moving along in our intestinal tract. 5, state which group nuts and beans would provide. Nuts and beans will be providing proteins in our diet. 6, suggest what GDA stands for. GDA is our guideline daily amount. Given our guideline daily amount, 6, suggest what GDA stands for. GDA is the guideline daily amount of one of our nutritional groups. So for proteins, it may be about 40 grams. So it is the guideline or the recommendation by the NHS that we should intake at least 40 grams of proteins. 7, suggest what BER stands for. BER is what we learned in this lesson. It is the basic energy requirement for an individual. 8, state the unit of BER. The unit for BER is kilojoules per day, the amount of energy that we must use per day. 9, state the equation for calculating BER, and you can find this 2 pages above. Daily basic energy requirement is equal to 5.4 kilojoules per 24 hours multiplied by your body mass. 10, state the unit of body mass. We do this in kilograms. Some of you might be more familiar in stone or pounds. However, because we are in science, we must make sure that we convert it to kilograms. 11, state the BER of a person whose body mass is 80 kilograms. So again, just like we did above, we're going to take our equation here, 5.4 multiplied by 24, multiplied by our body mass, which in this question tells us it is 80 kg. When you multiply those 3 numbers together, you get 10,368. And don't forget the unit at the end, which is kilojoules per day. Question 12. Same thing as question 11, 5.4 multiplied by 24, multiplied by our body mass, which in this question we know is 60 kilograms. And we get 7,776 kilojoules per day. Lastly, question 13, explain the difference in the BER values for question 12 and 13. Of course, we can see that one is larger than the other, but that's not what we're aiming for here. We want to know why one is larger than the other. So, as someone's body mass is lower, they would not need as much energy over the course of the day. The individual in question 11 has a larger body mass and therefore requires more energy. So with that, I hope you enjoyed lesson 4, and I will see you in lesson 5. Take care.